welcome to another set of video notes. And I have news for you. This is one of the last hard lessons that we're going to do in Chapter 3, because a couple of the next ones aren't so bad. And we'll get to those after break. But right now, we're going to look at this.
Joel Brutlog, please come to the main office. Joel Brutlog, please come to the main office.
See, this way you really feel like you're at school while you have those interruptions. So, we're moving on to 3-4. It says solve systems of linear equations in 3 variables. Now, if you think back, we've already solved systems of linear equations, only they had 2 variables, an x and a y. Well, now, if you look down here, you're going to see 3 variables. We've added one. There's an x and a y and a z, okay? And if you notice, we also have 3 equations, because you have to have at least the number of equations that you have variables to be able to solve these. If you look in your book, and I'll have you do this later, and I think I'll even ask you a question about it at the end, and have you write it in your notes to make sure you looked. When you do these, you would be graphing in 3 dimensions. So you still have your x and your y, but now we think about z, or how it's coming out at you. So now we're working with planes instead of lines. That part can get kind of confusing. So we're going to kind of pull out the couple things I want you to know from 3-4, and that's what we're going to work on today. Okay? One of the biggest things I'm going to ask you to do is I want you to see if an ordered triple is a solution. Now, if you think about that, triple means there's 3 numbers, an x, a y, and a z. You used to do things like checking to see if the ordered pair was a solution. You put in for x and you put in for y, and you wanted to see, do you have a true equation, or is the equation you've written, is it true? So we're going to try that today, and that's one of the biggest things I'm expecting you to take away. So, we list them in alphabetical order, x, y, and z. So if we want to see if this is a solution, what do you think you should do? I hope you all just realized, oh yeah, I need to plug them in. So 2 times x, well, let's see, x is 1. Minus y, y is 4. And plus -3, so that's like -3. And we want to see, does that equal -5? Well, let's see. 2 minus 4 minus 3. We don't know. 2 minus 4 is -2. -3 minus 5 equals -5. It does. It works. It's a solution. So, it satisfies that equation. Now we need to jump down and try this one. I think in terms of space, I'm going to come over here. Okay, so we write a 5. And we know 5 needs to be multiplied by x, which is just 1. We've got plus 2, and we need to multiply it by y, which is 4. We've got -2. We need to multiply it by z, which is -3. And we're thinking it's going to be 19. So let's see. 5 times 1 is 5. 2 times 4 is 8. -2 times -3. This could be tricky. Think about your signs. Yes, it's plus 6. Now, is 5 plus 8 plus 6 equal to 19? Well, let's see. 13 plus 6 equals 19. Yep, it's a solution for that as well. But even if you've checked it in 2, you still need to check the third one. Okay? So let's put it in. 1 for x, minus 3 times 4. Minus 3 because it's plus z, and we know z is negative. Okay, so what is negative, oh, I wrote the wrong thing, sorry guys. -3 times 4 is -12. 1 minus 12, -11, -11 minus 3. There's no way that's -5. So your overall answer here is no, it's not a solution. Now, if you find out it's not a solution on the first one, you might think, shoot, I don't have to do any more. Well, you might check, because maybe you made a sign error. Okay, we've got another one over here we're going to try. Same thing. I've given you the ordered triple, the x, y, and z, and I want to know, is it a solution to this system? So maybe we'll label them so we don't get confused. Let's come over here. 4 times x is -1. Minus, oh, this will be a good one, minus y. Well, y is a -2. So minus a negative, oh yeah, that's just like adding 2. Good job. And then you've got 3 times z, or 3 times 5. And we're going to see if that's 13. Well, what's 4 times negative 1? Negative 4. And 3 times 5 is 15. Okay? What is negative 4 plus 2? Negative 2 plus 15. Does that equal 13? It does. So it worked for that one. Let's go to the next one. Oh, this one's going to be easy. We just plug it in. Negative 1 minus 2, because it's plus a negative 2, which is like minus, plus 5. So does that equal 2? Well, let's see. Negative 1 minus 2 is negative 3 plus 5. Oh, yeah, that works. So far, so good. Let's see if the last one works. We're going to put in negative 1 here. We're going to put in negative 2 for y. And once again, we're going to put in 5 for z. Okay? We're hoping it equals negative 17. Negative 1, do the multiplication, you get negative 6, and you get a negative 10. Now, some of you might already know the answer, but let's go through. Negative 1 minus 6 is negative 7. Negative 7 minus 10. Yep, it's negative 17. So since it worked for all of them, the answer is yes, it is a solution. It is the one place where all 3 planes intersect. And your book shows a cool picture of that. So we'll look at that in a while. Okay? All right, so that's kind of the biggest thing and the easiest thing. We're going to move on to something else you'll have to be able to do. And that's solving these systems. And you'll notice I already told you you're going to use substitution. Okay? So remember, you pick one equation and solve for one variable. Just like we did before. You want to get one variable all by itself. Then you're going to plug that into another equation and solve. And you're going to just keep doing this process until you get the value for one variable. Okay? So, let's look here. This one looks pretty easy. It's got a plain y and a plain z. Let's work with it. And let's get the y by itself. How would we get rid of the z? Well, we'd subtract. So we get y equals negative z minus 5. Good so far? Okay, so one variable all by itself. Now, plug that into another equation. Well, look, right above it, we also have an equation that deals with y's and z's. So let's try using that one. Instead of writing y, we can use what we have here. Okay, so 3 times y, well, we don't want to use y. We want to use negative z minus 5, and then we've got negative 2z, and it all equals 0. Okay, so let's distribute. We get negative 3z, we get negative 15, and we get negative 2z equals 0. Okay, now, are there some like terms on this side? There are. Negative 3 and negative 2 combine to make negative 5z, and we set it equal to 0. Okay, what should we do next to solve for z? Well, this is just plain old algebra. You all are getting really good at this. So negative 5z equals 15. What would we do next? Oh, you divide by negative 5, and you get z equals negative 3. Excellent! Wait, we get the value for one variable. So now we can start plugging things back in. Remember how we did that? So now we're going to go back to that original equation. Y equals negative z minus 5. We're going to plug this in, and we get the opposite of negative 3 minus 5. Well, what is the opposite of a negative? Oh, it's a positive. Good. 3 minus 5, and you get y equals negative 2. Okay, well, we've got our z, we've got our y. What do we need? Oh, yeah, x. Hey, wait a minute, here's one with x's and y's and z's. Oh my, let's plug it all in. We've got 5x plus 2y minus 3z equals 0. Now look. We don't know x, do we? So we're just going to write 5x. Do we know y? Yep, right there. So we put negative 2 in. Do we know z? We do. Right here it's a negative 3. So let's solve. Well, this is 5x. This we know is minus 4. Hey, what happens here? Oh, I hope you all got it. It's a positive 9. Why is it a positive 9? Oh, yeah, negative times a negative is positive. All right, so you get 5x plus 5 equals 0. Good so far? Now, subtract your 5. Oh, this is getting easy. 5x equals negative 5. What are you going to do now? Divide by 5, and you get x equals negative 1. So our solution is x is negative 1. I'll circle it. Y is negative 2, and z is negative 3. Now, that can be pretty tricky, okay? And I surely don't want to give you a real messy one. And if you notice, I don't have any more written because we're not even going to worry about elimination. I will point out, for those of you wanting to challenge yourself, if you go in the book, it shows elimination. You're going to do the multiplying to get two variables to cancel out. You'd probably pick like these two and these two, and then you'd use what's left over and put them together. So lots of steps. We probably won't even look at it unless we just wind up with lots of extra class time. So be ready to come back and work on this, and I'll see you later. Bye.